Father Justin, Geek for My Youth. In this episode of the World of Code arc of the Geek Orthodox podcast, I would like to start, somewhat atypically, with a programming note. Actually, with a couple of programming notes, no pun intended. First of all, you might have noticed that in the last couple of episodes, I've concluded with an allusion to the Apostle Paul's allusion to the Greek poet who, when Paul quoted him, was saying of God that in him we live and move and breathe and have our being. Now, I obviously, as an Orthodox priest, don't want to be misunderstood here as referring to AI or computer code as God. Whatever the pretensions that AI may have, and we might get to some of those pretensions in a later episode, it is clearly not God. However, I do think, and this is obviously why I used it, that the ubiquity that is implied in that line does apply to the world of code in which we live. Namely, that, the very air that we breathe and some of the air conditioning systems that are controlled by code is, influenced and controlled by the world of code in which we live. The vehicles that we use to get around in are themselves now mostly equipped with computer chips. So again, the world of code is there too. So the intent here is, of course, simply to portray the ubiquity of this world of code. And something that ends as something that we just can't escape in the modern world. And therefore, I think, something worth looking into. The other thing is that, this podcast began and will continue as an audio podcast. I have, from the very beginning, thought that there are elements that video brings in certain situations that can be helpful. And in this case, I've deliberately produced a video version of the podcast as well as an audio one and posted it on my YouTube channel. And so I would encourage you, if you can, to go and check out the video version of this if you happen to be listening to this on audio. Because I think there are certain elements that helpfully will make it a little clearer and that are illustrative of the world of code that really can't be fully conveyed in the audio medium. So with all that out of the way, let's return to where we left off. We began with BASIC, a very simple computer programming language, which was ubiquitous to early computing and was my entry into the world of code, and which I'm using simply to illustrate how code works. And what we found as we began looking at this last episode was that computer code repeats remembered commands sequentially. It's a fairly simple summary of what we found. We found that computers have no problem with repeating things over and over and over again. Computers have a form of memory in which they can store values and also, more importantly, maybe not necessarily more importantly, but equally importantly, they also store commands. And that when computer code is executed, it generally follows a sequence. We did notice also that the sequence can be rearranged in terms of a loop, but we didn't point out that that sequence, because I got sidetracked, and I think it was a useful sidetrack, given that I also think it's important for us to consider how technology and its quirks change and shape how we use that technology, and therefore change and shape us. That's where we ended up getting sidetracked, because colored computer BASIC has a specific way of handling multiple inputs, which we ran afoul of, and that led to that tangent. However, computer code doesn't just execute commands sequentially. It also executes them conditionally. This is really important because if you want to use logic, you have to be able to test to see if something is, at the very least, true or false. If it's true, you probably want to take a course of action that is different than if it's false. So here, let me break into the program that I just used, this simple TRS-80 Color Computer PowerPoint program that I programmed in BASIC. And I want to list the program. And in doing so, I want to make a couple of points. One, you can see this is a much more complicated program than the one that we started out with. So complicated that all of the code doesn't even fit on the single screen. Secondly, what I mostly want to draw your attention to here is line number 150. So here, this is TRS-80 Color Computer Basics quirky way of handling keyboard input. So I've got a variable here called iString, which takes a string of characters, or in this case, a single character, from a dedicated command called inKeyString. So if there is any keyboard that any key that has been pressed on the keyboard, it will be stored in this dedicated variable called inKeyString. Or maybe you want to call it a command. I think it's kind of a system variable, but it doesn't really matter. The important thing is when we make this assignment, if there is any keyboard input, then it will be stored in iString. If there isn't, what will be stored in iString is an empty string. That makes sense, right? Now the colon here in line 115 is indicating that there's a second command here, and it's the second command that I really want to draw our attention to. Here we have an if statement, and this if statement is testing to see if if a certain condition is true. In this case, the condition is that we're testing for is to see if there is a nothing, an empty string, in iString. If there is, that means that no key has been pressed, and then we go back to line 115. That is to say, we go back to the beginning of line 115, and again, take whatever key is being pressed and put it in iString, and then we test to see if anything has been pressed, and if there isn't, then we go back to 115. In other words, this line here stops the execution of the program until a key is pressed. So very simple. It's actually two commands here. We pull the keyboard to see if any key has been pressed, and then if one hasn't been pressed, then we continue pulling the keyboard. As soon as one has been pressed, then we continue on in the execution of the program. And that's how, when I run the program, it waits for me to press the spacebar, and then again press whatever other key I want to press on the keyboard, and as I press them, it reveals, or rather prints out, the text on the screen. So the first thing then that I wanted to share here was this conditional element of programming. It's very important, and what it does, it allows for computers to interact with the data, the input that we give to them. And this, of course, allows these virtual machines, which are created in any computer program, to get complex, as we can see here. And actually, one of the things that I think is unique to computers, and this is the kind of the main focus that I want to look at in this episode, is that because computers are virtual machines, that is to say, they take our instructions and then just keep going with whatever instructions we give them, however complicated those instructions are, and keep going and going and going. There's almost theoretically no ending point for the complexity of this technology. Now, this is actually significantly different than most forms of human technology. Obviously, there's a limit to how complex a switch can get. You might have a switch that has multiple settings, and that's a little more complicated than a switch that's just on or off. And you might have more than one switch, but the switch itself is actually fairly simple. Similarly, if you take a more recent invention, Is it more recent? It's a good question. Take a very different invention, a chainsaw. A chainsaw is just really a motorized saw. And as the technology progresses, as chainsaw technology gets more and more complicated, the chainsaw itself gets changes and becomes more complicated, incorporating different elements, like perhaps a starter that makes it start more easily, or a different kind of engine to drive the chain. But the basics of the saw are dictated by the machine and the limitations for which the machine can be used. With computer code, there is almost no theoretical limit to how this can be applied and to what we can do with it. This means that as computer code gets more and more complicated, it actually becomes more and more difficult for us as human beings to monitor it, to keep tabs on it, to understand it. So one of the things I love about this TRS-80 color computer is that the operating system is essentially the basic programming language. The way that you control the computer and make the computer do things is you type in basic commands. Modern operating systems on a computer like the one I'm using to record this podcast have a wide variety of different aspects to them. I mean, if I look at my computer here and just look at the screen, we can see that there are multiple layers of this operating system, whether that be the file system, which is represented here in the little window I just popped up there, which has all the various files that are on the computer, not only the files that are that I'm using. And notice there's multiple different kinds of files here. Here I just have like a document. I'm working on a document that contains most of my poetry. Another document that is a PDF that's already been prepared. Some audio here that these are, I think, sermons of mine. These are files that I'm working with, but there are also on this computer program files that run the various applications that are on the computer. And these are also revealed to us by this window here that is itself a program. And there are layers upon layers upon layers of complexity here that are just a part of any modern computer system that are magnitudes of orders of magnitudes more complex than this basic computing starting point. And as we keep going, the complexity that we have gets to a level where it becomes impossible to know everything that's going on behind the scenes. Now, this isn't necessarily a problem. I mean, very few of us actually understand how all the details of how the car engine works in the vehicle that we use to get from point A to point B. All we need to know is how to operate it. Now, there are some interesting conventions that we've learned to operate a vehicle. So, for example, it's generally you put the key in the ignition and you turn it, and that turning of the key in the ignition is what causes the spark plugs to fire and begins the process of starting the engine. That being said, that's not the only possible way of starting a car. There are cars now with keyless ignition, where you just press the button. Some of you may have one. There are cars which no longer even ignite anything in the engine because it's a completely different technology under the hood. Electric cars are, of course, what I'm thinking of here. And while we don't need to know the technology, somebody does. Somebody needs to be able to work on and fix those vehicles when they break down. And so we while we personally may not know, the way that we have constructed our civilization means that somebody knows somewhere something about the engine of the car that will allow us to operate it. So this is the case with computer code as well. Because computer code has gotten so complex, nobody knows, or I don't think there would be very, very few individuals who would know how the code works on every level of a modern operating system that we use to use the technology that is the computer. However, the basic, no pun intended, reality of current computer code is that somebody somewhere understands it. And that as we keep working on this code, making it more and more complex, even if it gets to a point where, somebody who used to understand this code is no longer with us, or no longer interested in coding or whatever, somebody else can decode that code and can come to an understanding of how it works and change it and alter it and continue to service it. But it's interesting, again, as I say, there's no logical endpoint to this. Not like a chainsaw. There is a logical endpoint to a chainsaw. You might even have a chainsaw that is mounted on a vehicle and incorporates all sorts of different elements so that you have one of these massive machines that harvests the trees as a logging company might own. But again, there's still a certain physical limitation to how complex a chainsaw can get. Not so with computers. And I think this is particularly significant in what I want to return to as we are considering this world of code in which we live, which is that the next point in the development of our code seems to be that we don't actually understand entirely how it works. That potentially dystopian future, however, is something that I want to reserve for the final episode of The World of Code as we return to where we started, that kind of bridge episode where we began to look at AI. What I want to look at and focus on in the next episode is the embodiment of code. That is to say, in order to run computer programs, you need a computer. The nature of that computer, well, computers in general do allow for this almost infinite extensibility that I've raised, also does limit both how the computer programs run, the level of the complexity of the programs that can be run, and how we as human beings interact with the computers in this world of code in which we live and move and breathe and have our being.